Okay, students, so what we're going to do is look at an example of how to use the empirical rule, which is something that's just used when you have a bell-shaped distribution and you know the mean and standard deviation, and you want to make some estimates. It's easier than just counting out values. So let's say, for example, we have the useful life of a tire, a typical tire that you put on a car, has a mean of 40,000 miles and a standard deviation of 3,000 miles. We're going to assume that we have a bell-shaped distribution as depicted in this picture here. So the things to remember here, we know that 68% of the values are going to be within one standard deviation of the mean, which we know is this middle value right here. So I'm going to actually mark this with a 40,000. We know that 95% of the values are within two standard deviations of the mean, and 99.7% of the values are within three standard deviations of the mean. So what does that mean? Well, if I come back up here to my normal curve, so one standard deviation just means like one unit of measurement. So in this case, one standard deviation is 3,000 miles. So I'm going to come out to about here for one standard deviation, here for two, and here for three. And I'm going to try to mirror this the best way that I can on the left-hand side. Not bad. Okay, so that means this value right here, that is one mark above the mean, or one standard deviation, I should say, is 43,000, because that is 40,000 plus 3,000. Which means every time I go up one standard deviation, I go up 3,000 miles. So this is 46,000, and this is 49,000, and that means this is, whoops, how did that happen? That means this is 37,000, this is 34,000, and this is 31,000. So here's where we can start to answer some questions. So the first one is, 68% is going to be between, well, we know that 68% is within one standard deviation, so we're talking about this area here. Okay, so that means that those values are 37,000 and 43,000. So 68% is within 37,000 and 43,000. 95% corresponds to two standard deviations, so I'm going to draw that here. That means we just go out one more standard deviation than the previous, so that's between 34,000 and, 46,000. And finally, 99.7% is within three standard deviations, which is 31,000 and 49,000. Okay, so that's the information that we can get from the empirical rule. We can also answer other questions. So let's just look at, just two exploratory questions here. What if your friend told you that they bought 4 of these tires and one of them only lasted 30,000 miles? Well, what would that tell us here? Well, let's just say this is a manufacturer's claim. If a friend told you that they only lasted 30,000 miles, keep in mind that that's down here on the normal curve. Notice I put the X down there below the 31,000. This is what we would call very rare. And if you think about the histogram that would happen underneath of this, that means that 30,000 is so unlikely that maybe something is wrong. So maybe they have a case, maybe they can get a replacement tire for free because it lasted so little. And this is actually where warranties come from too. On the other side, what if a friend of yours said they got tires that lasted 50,000 miles? Well, that's up here. And what you would say is, well, maybe they drove a lot more safely than was assumed in the claim of 40,000 miles. So that case, it's a good thing, but it's still very unlikely because, again, we expect it to happen so little. Remember that within 3 standard deviations, we're talking about 99.7% of the time, which means 0.3% of the time, I'm either going to be here or here, which is so rare, again. Some other things we can look at, too. If you have a tire that lasts 42,000 miles, that's here. Now, that is considered pretty typical because it is close to the mean. In fact, it's within one standard deviation. Later on, we'll talk about rules for figuring out if something is unusual or not. But for now, as we can see, as you get further from the mean, as we talked about before, as you get further away from the mean, the values become less and less and less likely to happen. So I hope that's a nice introduction to the empirical rule for you. I hope this was helpful, and thank you for watching.